All right, so let's go ahead and do our 5.7 notes, which is graphing a system of linear inequalities, similar to the last lesson, but now we're going to have two equations, and yeah, so we're going to have two different shadings, and let's just see what happens. So first thing we want to do is just to test if something actually has a solution. So just like the last lesson, what we do is we plug in those x and y values, but we have to do it in both inequalities and just make sure it works. So let's go ahead and try this first one here. If I plug in my x, which is 3, and my y, which is 5, I'm going to get, oops, I was going to write y there. How about this? Let's write 5 less than 2 times 3, which 5 less than 6, which works. Let's try the second equation. 5 greater than or equal to 2 plus 1 is 5 greater than or equal to 3. Checked. So my answer here would be yes, it worked. Let's go over to example 1b and do the same thing. I'm going to plug in 0 for y. So this time I'm going to get, I guess I can write it underneath here. I'm going to get 0 less than 2 times negative 2. So I get 0 is less than negative 4, and that right there is no. So the whole answer is going to be no, because if that first one doesn't work, I don't have to test the second one. So go ahead and pause the video and do these next two on your own. All right, welcome back. You're going to get a no for this first one and a yes for the second one. We're going to now move into big content today, which is we're going to graph what we did yesterday. Well, the last lesson, which are our two lines. We're going to shade on both sides. But where the shading overlaps is our answer. Um, so you can shade with two different colors. You can shade with your pencil. Some people do an arrow method. I'll show you both. But we just want to see basically where the two shadings would overlap if you do two inequalities like we did in the last lesson on the same graph. So let's look at example number 2 here. We have y less than equal to 3. So that is going to be a horizontal line. That's a solid line here. And if we test 0, 0 for this first one, 0, 0, I'm going to get 0 is less than or equal to 3, which is a yes. So I want to shade underneath this. Here's my shading. Now I'm going to go and do the second equation, which is y greater than x plus 2. So that is a y-intercept of a 2. Right, and so now we're going to have a y-intercept of 2 and a slope of 1 over 1. So I'm going to connect these. And this is a dashed line. So I might just actually keep these dots here because it looks pretty much like a dashed line. And if I test 0, 0 here, I'm going to get 0 is greater than 2, which is a no. So I don't want to shade where 0, 0 is. I want to shade above this. So I'm going to go everything on this side. And where our overlapping happens is our solution. So our solution is actually this area right here where the two shading spots overlap. So I'm going to do that in a different color. So there's my solution area right there. Let's go ahead and now do example number 3. First things I want to solve for y. I want to get y by itself so we can do slope-intercept form. So my first inequality is going to get me y less than negative 2x minus 1. And my second one is going to get me y greater than negative 2x plus 3. Now I can already tell these are going to be parallel lines, but let's just see what happens here. Let's graph the first one. So here's negative 1, go down to right 1, down to right 1, and I'm actually going to use my ruler here to make this a little bit easier. So now I have some points here. Oops, helps if I don't move my screen. Okay, that was supposed to be a dashed line, so I'm going to go through and make sure that is dashed here. So dash, dash, dash. And maybe make that just a little bit smaller. There we go. So there's my dashed line. And then if you don't want to do a shading method, you can do a little arrow method. So if I test 0, 0 here, I'm going to 0 is less than -1, which is not true, which means I want to shade everywhere on the other side, which is me shading away. And then wherever the two arrows point to each other when you have the other line is where you will have your overlapping area. Let's do the next inequality. I'm going to start at 3. And then again, this is down 2 over 1, down 2 over 1. We're going to graph this line. This is also a dashed line, so I don't screw this one up as well. Okay, so there's my dashed line. My arrows are on here. And if I test 0, 0, I'm going to get 0 is greater than 3, which is not true. So I'm going to shade away from where 0, 0 was, which is above here. And so you'll notice my arrows are saying I'm shading away. Now, if you do want to do the shading, here's what it would look like. This top part would be shaded here. The other part would be here. You'll notice there's no overlap. And because there's no overlap, that means our answer is going to be no solution. All right, go ahead and do the 3 on your own, and then I will quickly go over them with you. All right, let's look at number 3 here. I'm going to have a intercept of 4, 1, 2, 3, 4, and a slope of -1 over 1. So I'm going to quickly do my solid line here. If I test 0, 0, I'm going to get 0 is greater than equal to 4, which is not true. So which means I'm going to shade on the other side, which is right here. So there's my shading. And now I'm going to do the second equation, which should be written as y less than or equal to -x. So that's at 0, 0. And my slope is a -1. So it has the same slope as the question before. So let me go ahead and graph this one. It is also a solid line. Now, because I can't test 0, 0, maybe I can test like 0, 1. So if I test 0, 1, which is going to be right above there, I'm going to get 0 here, 1 here. Is 1 less than or equal to 0? No, which means I'm going to be on this other side here, and we have another no solution question. So this one is a no solution. Let's look at number 4, intercept of -3. I'm going to go up 2 and over 1. Do that a few times. And this one is a dashed line, so maybe I'll just keep my points here. If I test 0, 0, I get 0 is greater than -3, which is true. So I'm going to shade everywhere on this side of the line. Let's look at the next equation. I'm going to start at 1. I'm going to go up 1, right 2, down 1, left 2. This is a solid line. I can test 0, 0. I'm going to test right here. I'm going to get 0 greater than or equal to 1, which is a no. So I'm going to shade on this side. Now notice my arrows here. The only place that they're both in the same spot is this section right here. Oh, let me go back to a highlighter here. This is my area. And then question number 5 for on your own. You should have the first equation should be y less than 2x plus 4, and then you could have had y greater than negative 2x plus 4. Both of these are starting at 4. So let's start through the first equation. 1, 2, 3, 4. And this first one is a slope of 2. So I'm going to go up 2 and over 1. Go backwards, go down 2, left 1. It is a dashed line, so I'm just going to make sure it looks dashed. If I test 0, 0, I'm going to get 0 less than 4, which is true. So I'm going to go ahead and shade on this side right here. Now I'm going to do the next equation, which I'm going to start at the same intercept, but I'm going to go down 2 into the right one because it has a negative 2 slope. I'm going to go backwards. It's also a dashed line, so I'm going to make these dashed. What I forgot to put arrows on my lines in this question, so I'm going to go back and put arrows. Then if I test 0, 0, I'm going to get 0 is greater than 4, which is not true. So I want to shade on the opposite side of where 0, 0 is, which is everything over here. You can sort of see where the overlap is because it looks sort of purplish. So there we go. There it is. I might try to get this a little bit. There. All right. So there's the on your own. Now let's go ahead and do example number 4, which is writing your inequalities. So let's look at maybe this first line, this first one right here. It has a y-intercept of 0 and a slope of up 1 over 1. So this is going to be something like y on one side, and then you're just going to get an x plus 0. Now, because we're shading underneath that line means less than, and it's dashed. Let's look at the second equation. This one is a horizontal line, so we have a y, and it goes through negative 2. There's no x, and because we're shading above it and it's solid, that's a greater than equal to symbol. For example, number 5, let's look at our first equation here. I might do the x with a 3, and when you're shading to the left, that's going to be a less than, and we'll do an equal to because it's solid. And then this other line has an intercept of negative 1 and a slope of up 2 and over 3. So you're going to have a y, you're going to have a 2/3 x minus 1, and we're technically shading above it, which is a greater than symbol because it's dashed. So go ahead and pause the video, and then you can do these two on your own. All right, for number 6, you should have x less than 3 and y less than negative x plus 2. And then we're going to have, for number 7, we're going to have y greater than or equal to negative 1/2 x plus 1, and then y less than or equal to 2x minus 3. All right, well, there you go. And that's the rest of our notes for the day. If you have any questions, please reach out and ask for help.